Hey guys, welcome back. We are talking about 3.2, 3.3. This is R selected and K selected species and their relative survivorship curves. Now you may be asking, what happened to 3.1? 3.1 was an introduction to generalist versus specialist species, and we actually talked about that in Unit 2 when we talked about biodiversity. So we are skipping 3.1, kind of, we did it last unit, and we are moving straight into 3.2 and 3.3 as we start our new unit, which is populations. So our learning objectives for today are explain survivorship curves and identify the differences between R and K selected species. So what are R and K selected species? This looks like a lot of words. R selected and K selected species are sometimes confused with generalists and specialists, but it has more to do with their reproductive habits and relative reproduction strategies. And so I'm actually going to start on the right here. I'm going to talk with R-selected species, but it is a classification of a species. And again, depending on their reproductive habits. R-selected species in general tend to be much smaller in size. They tend to have multiple offspring, low amounts of parental care. They tend to reach maturation very early. They have very short lifespans. They may only reproduce once in their lifetime, and that reproductive event will be relatively large, meaning they'll have like hundreds of thousands of offspring versus just one or two. They tend to be able to thrive in what we'd call a disturbed environment, which means they are more similar to something like a generalist. Not all R-selected species are generalist species, but they do tend to have a wider range of tolerance than a K-selected species. So some examples of an R-selected species might be cockroaches, rats, small fish, etc. So these types of species tend to not have very long lifespans, be small in size, reproduce once, but produce a lot of offspring all at once, and they generally mature very early, meaning they reach reproductive maturity very early. Versus a K-selected species is essentially all the opposite of those things. They tend to be much larger in size, so think large mammals. They tend to have very few offspring / reproductive events. They may only have one or two offspring in their entire lifetime. They reach maturation or reproductive maturation very slowly, which means it could take a decade or so for them to reach a point where they're able to produce offspring. They generally have longer lifespans. They have a high amount of parental care to their offspring, meaning they take care of their offspring for a long period of time. Whereas, and I don't know if I said this in R-selected species tend to not take care of their young. R-selected species have hundreds of thousands of young and they may never actually see them. Whereas a K-selected species is going to have one or two offspring and take care of it for many, many, many years or for a longer period of time. They tend to thrive in stable environments, so this is more similar to a specialist species. Their range of tolerance is generally going to be much more narrow, and they are going to be highly affected by any type of disturbance to their ecosystem. So some examples of that may include elephants and whales. Now, let me give you an example that you'll be really familiar with. Humans, for instance, are mammals that are K-selected species. We are much larger in size than a lot of other species. We tend to have fewer offspring / reproductive events. On average in the United States, women have 1 to 2 children. It's actually at 1.5 right now, so not quite 2. So we tend to have very few offspring. It does take a long time before we're actually able to reproduce. This would be the onset of puberty. Sometimes takes anywhere from 13 to 15 years for the onset of maturation where offspring can then be produced. Our lifespans are anywhere from 0 to 100 years, relatively speaking. In this class, we generally say humans have a lifespan of about 100 years. So we have a long lifespan by comparison to something like a mosquito, which may only live for like 3 to 4 days. We have a high amount of parental care to our offspring. We take care of our offspring for quite literally decades almost. So we spend a lot of time preparing our offspring to go out into the world. And we prefer a more stable environment. We have a range of tolerance where we're very specific with our temperature, we're very specific with the amount of water we have, etc. Other examples in nature, elephants, whales, both of these species are larger mammals that reach maturation very slowly. They're not able to produce offspring until 15 to 20 years into their lifetime. They may only have 1 to 2 offspring, and they will take care of their young for 10 to 15 years before their young are kind of sent off to live on their own. And they are most definitely larger in size. So those are some pretty characteristic case-selected species. And then some R-selected species. We've got cockroaches, rats, small fish. Rats, for example, have a lot of offspring all at once. They don't really take care of them. They do have a shorter lifespan, not necessarily in the days range, but, a couple years, which would be a relatively short lifespan compared to something like elephants or whales, which can live decades and decades and decades. A lot of offspring, they don't really take care of their offspring. They can kind of survive in a really large range of tolerance. They reach maturation very early on, within a couple months. So those are pretty characteristic R-selected species. And so this is just another way we can further classify species based on their reproductive habits and their level of care post-reproduction. This is just kind of a summary. So if you're looking for a quick guide, you don't have to do anything with this. It's just as you're studying maybe for your next quiz or test, this is a quick reference. Now with R and K selective species comes something called survivorship curves. And this is a pretty characteristic graph that you will see on the AP exam, and it's called a survivorship curve graph. And it represents the distinct patterns of survival based on their age. So I'm actually going to come back to the slide, but I kind of want to show you what the survivorship curve looks like. And so it will always look like this. There's a type 1, a type 2, and a type 3 type survivorship. Type 1 is always associated with K-selected species, and type 3 is always associated with R-selected species. And then type 2 is somewhere in between. Now, type 1 species, you'll notice on the curve, so this is age increases, and this is how many individuals are surviving over time. So you'll see that type 1, these K-selected species, so things like humans, whales, elephants, have a really high survivorship for a long majority of their lifetime. And then as they age, they slowly start to taper off. And so this is consistent with the human lifespan, where, a lot of us survive for a really long time, and then as we age or get older, then we start to see the tapering off. Whereas in a type 2 survivorship, we have very low survivorship very early on in life. We see that decrease happening very, very drastically, and a low amount making it to an older age. And then type 2, this middle one is a constant decline in survivorship over time. And so they give you the example of the squirrel. So they aren't quite a type 1 or a type 2. These are really the hardest ones to identify. And for the most part, the AP exam is not going to give you a type 2 identifiable species. It will give you something that's a little more specific, like, is this type 1, is this type 2? And if you're not familiar with the species, or if they choose something that's sort of unique, they would have to give you some type of parameters or some type of insight into their reproductive habits for you to sort of understand what their level of survivorship looks like. Now let me go back to the slide. So this is just a quick summary of the 3 types of survivorship curves. A type 1, which means there's a high survival rate through most of the lifespan, but then they start to die off as they age. Type 3, a pattern of survival over time where there's a low survivorship early in life, and then very few reach an older age. And then a consistent decline is type 2. Okay, this was very short today, so think about this. When we see each other on Thursday of next week, we will go over this a little bit more. Okay, have a great weekend. Thanks.